Hello, welcome to my garage. In this video I'm going to show you how to fix a common problem with the Ducati Multistrada, a broken fuel level gauge. Well, this part has been removed and I replaced it to a new one, but just for the record, to get access to it, you need to remove the seat, the side body panels, the front side panels, its support, the tank fairing, and you have to remove the fuel tank to get access to the fuel sender gauge. To remove the fuel level gauge, there's a ring nut that needs to be loosened. There's a special Ducati tool for it. If you would like to buy it, then that's okay. It's an equal price as for the unit itself, but there is another solution. I find it by using common socket wrench. It's a size 50. The only thing to do is to cut out this hole for the cable. It's a bit of oversized piece of tool, so I'm gonna cut it and make it a ring with a bit of welding work, but it will be the subject of another video. Well, while it's in the bike, the only thing you can see that there are stupid fuel levels shown in the instrument cluster, or it constantly shows empty tank. This unit is a passive unit. It means that it doesn't contain any active electronics. Briefly speaking, it contains resistors and reed relays, the summary, and there's a float that contains a magnet. Under normal circumstances, when the float is moving up and down, there are different values of resistance can be measured in the output. In this case, I can see then while the float is moving, there is nothing but open circuit. To find out what would be the root cause for it, we need to disassemble the fuel level gauge, and for that we need to remove this kind of torque screws that fix the covers on both sides. On this side, that's okay. The torque size is T10, so pretty much small. But on the other side, when we remove this, you can see that there's the epoxy resin that fills up this hole. These three holes are made by myself because I drilled them out to get access to the screw heads. For this work, you need to be very careful as not to harm either the cable or the head of the screws. When it's finished, then you need to disassemble the unit itself. Let's see how it looks inside. We've got the 6 screws out, so we can remove the cover, and also to remove the float. Now you can see that in the plastic there's a magnet, and you can also see that there is a gasket to separate the two chambers of this tube, because in this side there's a PCB. It shall be insulated against the fuel. That's why we've got the gasket here. While in the other chamber, it's free to the fuel to go in and make the float move. And removing the other side, we are able to get access to the PCB itself. And yes, this is the root cause of our problem. So we need to make some measurements to find out which part is broken. Well, after initial check, the resistors and the reeds are okay. But I also made, first step, to check the wiring itself. This lower line is for this contact. So there is contact. It practically should be a short circuit. But when I choose the other line, this is the upper one, I can measure nothing. It's open. It means that there is a break somewhere inside the epoxy resin. So what I have to do is to completely remove the resin around the wire, remove the PCB and resolder it. Well, I can tell you guys that removing epoxy resin in the mostly civilized way sucks. What I found was not what I expected, because it was a broken contact and it's not a soldering. It's a sliding contact, most probably sliding contact, but I was not able to remove all the resins and disconnect the PCB. Well, we've got two choices now. Either scrap this unit or try to fix it. Now I would like to tell you something about this kind of failures around these electronic parts. This fuel level sender gauge is at the bottom of the fuel tank, right above the cylinder. It means that it gets an excessive heat load, and there's a big variety of temperature around. And it often happens that this type of heat change lead to micro cracks on the soldering. Why? Because there is a phenomenon called heat extension, and the PCB as a plastic part extracts, expands in a different way than the metal parts and the ceramic parts. And sooner or later there are micro cracks appears in the soldering area. It's called meniscus, and yeah, most cases it drives us crazy, because it means that the failure itself is not permanent. Sometimes comes up, sometimes disappears. Why? Because the thickness of this micro crack changes when the temperature changes. And for example, when there's a low temperature and there is a contact, when the heat emerges, then the crack is going to expand, and then there's a point when the contact is lost. In this way, a simple resoldering solves the problem, but not this case, because there is no soldering. What I can do is to try to put them together by soldering, and then fill it in with epoxy resin as thick and as massive as possible, because this kind of phenomenon happens when there's a vibration, a permanent vibration, and we know that Ducati has got vibration in the engine block. So next step is to try to solder the contact, and we see how it works. Okay, soldering has been done, and it seems that it was successful. it looks massive enough. But yes, this is not a quality solution, it's a kind of first aid. Next step is to fill it up with epoxy, and we'll see how it works after that. Well, that's it. The job is done. What I made after explaining what I'm going to do and after the soldering was that. So in the first step, before I filled it up with the epoxy resin, I've made the plastic wall strengthened, because due to the milling it was inevitable that there were some damages. So I used this kind of two components epoxy called auto weld, and considered the strength and resistive enough to strengthen the plastic wall and the area around the soldering. And finishing it, I use this kind of two component epoxy resin. The main feature was that this is thin enough to fill up all the holes, scratches, all the area inside the milled out part. So this has got 1.1 gram per cubic centimeter viscosity. That means that it's barely thicker than the water. So that's why it is useful. The time for the full strengthening is some 2 weeks, but I think it's worth. Well, what I did here by fixing the gauge was a kind of experiment. An experiment because I did not fix the usual crack of soldering by resoldering it. I mean, using the same material. But I replaced some materials inside the gauge. I mean, the epoxy resin is now different, and I fixed the broken copper connector part not by replacing it, but by resoldering it, because replacing it could have been an excessive work that I decided that it's simply not worth to me. But considering that the original gauge, I mean this one, lasted 41,000 kilometers, I hope that this one that I've already installed lasts at least another 40,000 or more. But anyway, should this one breaks in the future, I will be here with the new video and we'll find out what's happened and how to fix it. So in case you have a Ducati or you are simply interested in this kind of stuff, then you are welcome to my next videos. See you.